Hello class, Miss Emami here. I hope you're all fine and doing well. In this lesson, we are going to talk about correlation coefficient and learn how to calculate it and use it to determine the kind of correlation between two variables. The other name for the correlation coefficient is Pearson's R. That's why we will use the letter R to represent it. The limitation of the covariance was that the result or the number would be dependent on what kind of data we are calculating the covariance for. So it was very difficult to apply to different data sets. However, in terms of correlation coefficient or Pearson's R, you will always get a number between -1 and 1. So what happens here is that the correlation coefficient tells you two things about your correlation. First of all, depending on whether you get a not positive number or a negative number, you will know if you have a positive correlation or a negative correlation, meaning that if the independent increases, is the dependent going to increase or decrease? So by looking at the sign of this number, you will know what kind of correlation you have. It will also tell you about the strength of the correlation. So I am going to show you a spectrum here. So this number goes between -1 to +1 here. Now, -1 here means perfect positive correlation. And -1 here, perfect negative correlation. 0, if you get your Pearson's R to be 0, that means no correlation. There is no correlation. It's just random data. Now, between 0 and 1 and 0 and -1, this is going to be divided into 3 parts. So this is going to be 0.33, 0.67, and this is going to be -0.33 and -0.67. Now, anything between 0 and 0.33 or 0 and -0.33 is considered weak correlation. Anything here between 0.33 and 0.67 or -0.33 and -0.67 is called moderate correlation. And anything between 0.67 and 1 or -0.67 and -1 is going to be considered a very strong correlation. Now, so you will decide about the weakness or the strength based on the number you get here, and then whatever is positive, if R is positive, you know it's a positive correlation, and if it's negative, it is a negative correlation. Now, let me introduce the formula. Don't be scared. Even when we had exams, we would give you the formula. We were not expecting you to memorize this formula. However, you have to know how to use it. So in order to find R, N is the number of points that we have. It has to be multiplied by the sum of X times Y, and then subtracted the sum of X times sum of Y, and then we have to find the square root of N times sum of X squared minus sum of X squared times N sum of Y squared minus sum of Y squared. So not only we have to find the sum of xy, sum of x, and sum of y, we also have to find x squared and y squared and add them up. So let's go and do one. In this example, we are going to find the correlation coefficient, or Pearson's R, for this data, which is we have some data that shows the number of years in college or after high school education versus the starting salary per year for the first job. So 0 means someone who will go and find a job with no further education after school, and so on and so forth. And this information is given to us in K dollars, so like $1,000, so 15,000 or 20,000 or 25,000. Now, in order to find the Pearson's R, so not only we are going to find the Pearson's R, or coefficient or correlation coefficient, we are also going to use it to classify our relationship. Now, the first thing I'm going to do is I am going to rewrite the formula here. So R equals N sigma x y minus sigma x times sigma y, and in the denominator we need square root of N sigma x squared minus sigma x squared, and this is going to be multiplied by the same thing for y. So N sigma y squared minus sigma y squared. So that means we need to find x squared, we need to find y squared, and we also need to find x times y, because we need the sum of all these numbers in our calculation. So let's get started. 0 squared is 0, 1 squared 1, 3 squared 9, 4 squared 16, 4 squared 16, and 6 squared is 36. Now we are going to find y squared. So 15 squared is 225, 225, 20 squared is 400, 25 squared is 625, 30 squared is 900, and 35 squared is 1225. Now we need to find x times y. So 0 times 15 is 0, 1 times 15 is 15, 3 times 20 is 60, 4 times 25 is 100, 4 times 30 is 120, and 6 times 35 is 210. Now we need to find the sum of all these numbers here. So here sigma x is actually 18. We need to find sigma y, which is, we add up these numbers, we get 140. Sigma x squared, we add up these numbers, is 78. Here is sigma y squared, which is 3600. And here sigma xy is actually 505. So now we are ready to put all these numbers in the formula. So R equals n, and we have 1, 2, 3, 4, 5, 6. So in this case, n is 6. So 6 times sigma x5, which is 505, minus sigma x times sigma y. So 18 times 140 over square root of n, which is 6, times sigma x squared, which is 78, minus our sigma x is squared, so 18 is squared, times n, which is 6, times sigma y squared, which is 3600, minus sigma y, which is 140 squared. Depending on what kind of a calculator you have, you may be able, if you know how to calculate properly in your calculator, which most of the scientific calculator actually does it right now, you can calculate this in one go, or some of you may end up doing the denominator first and then numerator first and then do the division. So I'm going to show it to you how to do it. So if you put the numerator, you will get 510 square root of, you can do this first bracket first, which is 6 times 78 minus 18 squared, which is going to be 144 times, then do the second bracket, which is 2000, and the answer will be R is approximately 0.95. So now we are ready to decide about the correlation. We know that it is a strong positive correlation, meaning that it seems that the more years you spend in post-secondary education, your starting salary, at least at the beginning, will be higher. Homework is from textbook, and it will be posted on your Google Classroom. Be safe until we have another lesson. Goodbye.